Alrighty, hello and welcome. We're going to be setting up a GPU-equipped Linux instance. You can see I've actually already been playing around with one of these here. I created one called new Linbox. It's a G4DN.X large. So this is an instance that has a NVIDIA GPU attached. I think it's a T4. It's one of the cheaper GPU instances, so I use this as sort of like a graphics desktop for playing around with text-to-image models and doing stuff in Blender, 3D animation, that kind of thing. It's probably the cheapest type of instance for that type of work. Again, it's about 50 cents an hour. And you'll see I'm in the Oregon region here. That's one of my favorite AWS regions to use just because it has most services, even some of the lesser known AWS services like Workmail, those kinds of things are available in Oregon. So I like that one. Oh, don't disturb. Good. All right, so I'm going to click on Launch Instances, and we'll go ahead and make a new Linbox. So new Linbox, I'll choose Ubuntu. I'm going to choose Ubuntu 22. So the default right now is 24, which is newer and better in most ways. But I have some software that I'm going to run that runs better on 22. So we're going to go with Ubuntu 22, which I've just selected. You'll notice a little pop-up came up warning me that I need to, that some of my instance settings will change. That's fine because I haven't actually finished configuring everything here. So any settings that changed, I'll just restore them to the correct values as we go through this page. All right, so again, name is set. We chose Ubuntu, we chose 22. We're going to stick with x86. You could go for an ARM style instance. If you wanted to use a Graviton instance, that's what you would pick. Graviton instances have really, really good price performance, but they do not come with a GPU. So we're going to stick with x86. I'm going to do G4DN.X large. You can see that's about 52 cents an hour because I'm not using one of these operating systems that requires a license like Red Hat Enterprise or Windows. So it's going to be cheaper for me, 52 cents an hour. Choose an SSH key. Whenever you set up an EC2 instance, and I'll probably do a separate tutorial on all these other settings, like how to create the SSH key and the network group, the VPC. But whenever you create an instance, you have to give it an SSH key and assign it to a VPC, a network group, give it a subnet, say whether or not you want an IP address automatically assigned. All that stuff has to get done up front when you're creating the instance. So I'm going to click edit here, right here, edit in network settings. We'll click on that. This is my public VPC network group, so that's the right one. We're going to go for the public subnet in US West 2A. That's zone A in US West 2. I do want IP addresses automatically assigned. In my case, I don't really care if I get an IPv6 address or not, but I definitely need an IPv4 public address. Okay, create security group. We are going to go with select existing. We're not going to create a new one. I have a default group that's already configured the way I like as part of this VPC, and I don't need any extra network interfaces or anything, but you can attach additional network interfaces to your instances. Again, that's something we'll hopefully look at in future videos. I want 128 gigs of disk. I'm going to pick GP3, which is the most high performance general purpose block store. So this is like the highest performance type of EBS volume in the general purpose class. If I wanted something with better IO throughput characteristics, there's IO1, IO2. If I wanted something that's just like really good for like consecutive read, consecutive write, like maybe storing a bunch of logs or other data where like price per gigabyte is really important. There's magnetic disks, like real old school hard drives. I don't need that. We're going to go with GP3. I do want to open up advanced though, because I personally like to have all my hard drives be encrypted, and I have a couple KMS keys set up for that. This is the one I want to use, EBS key. I don't need to change the provision throughput here. The default is fine. I do need to go into advanced details. There's one thing I really need to change in here. I don't need to create any startup scripts or change the shutdown behavior or any of that stuff. But I do need to go into the IAM instance profile here and add EC2 power user. This is sort of an administrator IAM profile. This will make sure that when I run the AWS CLI, the command line tools from the instance, I'll be able to do all kinds of stuff, like, communicate with Poly for text-to-speech, talk to my S3 buckets, all that stuff. All right, so now that we've changed all those settings, the last thing to do is to click on Launch Instance, and we'll wait a couple of seconds, maybe a minute, and then our instance will come up. So you can see it's been initialized. If I go back here, I go to my running instances list, you can see it's coming up now. And we'll go ahead and fast forward to when it's ready to use. All right, so after waiting a couple of seconds, well, about a minute, we should be ready to go. I'll click on the instance ID, and you can see all the properties of the EC2 instance we've created. And again, if you don't know what all this is, that's fine. No worries, we'll be covering some of this later on in other videos. What I really care about here is connecting to the instance. So because of the IAM profile, the permissions that I've attached, this role here, actually, it's a role. Because of this IAM role, I can use a built-in tool, the session manager, to actually connect to this instance. So even if I don't open port 22 in the security group, I can actually directly connect via SSH to this instance through session manager, which is pretty sweet. I don't even have to worry about putting in my SSH key details or anything. It's just it's a built-in service that's included in most of the official AMIs, the official Amazon machine images, which are like boot disk images that are used to boot up EC2 instances, including the Ubuntu 22 image that we're using. So what I'm going to do is let's do sudo and then switch user, and then we will change to Ubuntu. Right? Great. So now we're on our wonderful machine here, and you'll see that it does indeed have a Tesla T4 GPU attached, right? So it's showing up here. However, none of the drivers for that are installed, right? NVIDIA SMI is not installed. If I do lsmod, you'll see there's not any kernel module for that yet, so I haven't built that. So if you are using the default Ubuntu 22 image, it doesn't come with NVIDIA drivers, so you're going to have to install those yourself. That's one of the first things we're going to do here, and then as we do that as well, actually we're going to go ahead and install the GNOME Display Manager and Ubuntu Desktop. So all the tools that come with Ubuntu Desktop are not part of the image that we're running, so we need to do a couple of things. Let's take it one step at a time. So what we're first going to do is go ahead and of course do the thing you always do, right? When you boot up a new Linux machine for the first time, we're going to do update and upgrade. So we'll do that first. Very important, right? Git upgrade, and I'm sure there will be some updates, and sure enough, you can see there's a bunch of stuff here that needs to be updated. So we'll do all that, and we'll wait for that to happen. And then once that's done, we'll keep continuing on here. Okay, so we just say yes to this. Let me hit tab and then enter. We're going to be rebooting a bunch of times as we go through this, so no big deal. It doesn't actually matter which services you choose to restart. Okay, if we want at this point, we can do like apt get auto remove and auto clean. These will remove leftover packages and stuff that's been orphaned. Okay, you don't necessarily have to do that. You can actually see just now there was nothing to remove. What we're going to do next is -y is going to say yes to any prompts that the installer has for us. So we'll put that in just so we don't have to sit here and say yes, yes, next. So apt-get-y install, and then we are going to install GDM3 and Ubuntu Desktop. I think Ubuntu Desktop might actually pull in GDM3 on its own, but just to be safe, we'll write them both in there. And this is going to take a minute. This is quite a few hundred megabytes of packages. Turning Ubuntu server into Ubuntu Desktop involves installing a ton of stuff. So I'll come back when this is done. All right, so while I was waiting for that to finish, I actually got disconnected from my session manager session here, and I wasn't able to get back to the terminal where I had run apt-get. The process was still running in the background, but I had to kill it. So I just did kill and then the process ID, which I think was like 8192 or something. You'd have to look that up with ps-e. So I just did that, and it turned out it was still running, but I couldn't access it. I couldn't figure out if it was ever going to finish. So let me show you a trick for avoiding that, right? Actually, what I should have done, and what you should always do when you're running over SSH or through Session Manager, is you should do all of your work, all of this manual work that you do, inside of like a terminal multiplexer tool like Tmux or Screen. I like Screen, which is built in. If I just type the word Screen and hit enter, you'll see it says, okay, you're in Screen. If I hit return or space, I just go back to the console. It doesn't look like anything has happened, but if I now do Screen-R, you'll see there's this screen session here, right? And it's got its own process ID, its own name, and it says attached. That's where I am right now. So now this shell is sort of a floating shell that I can reattach to anytime I want. If I wanted to leave it, I would just do Control-AD, and you'll see it says, okay, you're detached now, right? If I go back, we're in there. So actually from within this shell, let's try and fix the install process we were doing. So we'll just sort of sudo apt-get update and upgrade. We'll just try to sort of resume from where we left off. Upgrade. Okay, and you'll see it's not happy because it was in the middle of configuring and building some packages for me when I killed apt. So we'll do that. Hopefully that fixes everything. Yeah, so it looks like we're now continuing from where we left off. But let's say, oh no, I make a mistake. I hit the terminate button. Oh shoot. Oh darn. Or I lose my connection or whatever. Well, great. Now that terminal session, that session manager session is gone. If I hit connect and I reconnect, you'll see I'm now in a new shell. I get dropped into a new shell, right? If I go back to the Ubuntu user, there's nothing for me to see, right? I can see if I search for it, sorry, grep, that, sorry, I guess dpackage would actually be running. I can see that it's running, but I can't see where it is. I can't control it. I can't look at the output. But that's okay, because I have my screen, right? If I hit Screen-R, like I just did, I reconnect. Control-AD to leave, Screen-R, get back in. Control plus A and D, and you have to hold them all down together, right? So again, that's Control plus A plus D. It's actually, you don't need Shift, so I'll do lowercase a and D. Control-AD to leave, and then to get back in, Screen-R, right? Just those two. Got it? Just these two. All right, so we'll do that. We'll go back in here. Oops, sorry, clear Screen-R, and you can see what's going on. So it doesn't look like I broke anything, and we're able to continue on. I really should have been in a screen session this whole time, and I recommend on Linux, especially if you're connecting to a remote machine like I am, it's a really good idea to do everything inside of one of these Tmux or screen sessions. Some people really prefer Tmux, which is sort of like the screen alternative. Screen is a built-in in Ubuntu, and I use Ubuntu most of the time, so that's why I use screen. Yeah, and there's all kinds of cool stuff you can do, like split view, where you can have multiple screen sessions open at the same time. I don't play with any of that. I just use my screen sessions one at a time, but you can get fancy. All right, so you can see we are now done. So again, just because I'm paranoid and to make sure I didn't break anything, I'm going to run update and upgrade one more time. I'm going to rerun the GDM and Ubuntu desktop install commands just to make sure we didn't miss any packages. Upgrade. It also looks like we may have rebuilt a kernel. All right, so the following packages are no longer required. Oh, okay, good. So those are packages we can remove with the auto remove and auto clean commands. So we'll do that in a second. First, let's just make sure GDM3 and Ubuntu desktop really installed everything they were supposed to. Looks like they did, and then we'll do sudo apt-get auto remove. Yes, you can remove those packages we don't need anymore. Thank you. It's a very handy feature in apt. Okay. Again, I don't really care what services I restart because I'm going to be rebooting in a second, and we'll do sudo apt-get auto clean. Okay, we cleaned, fantastic, and just to be super duper safe, I'm going to go ahead and reboot. And you'll see screen has terminated, and of course my session here in Session Manager is no longer connected to the machine. This is sort of a dead virtual shell now. So I'll hit terminate, and we'll come back in a second when the machine is rebooted. All right, so we're all good, we're all reconnected. If there's no screen session, which there won't be because we rebooted, then we go ahead and make a new one. And first things first, you know what, I'm gonna run apt-get install, and then we'll reinstall package config and cmake data. There's some build steps later on that I've found will generate complaints and warnings if we don't do this. I don't think it will actually impact our ability to build the NVIDIA drivers, but just in case. All right, so there we go. We're good to go there. Let's make sure that GDM3 is set as our display manager, which will tell us whether or not that installed correctly. It did. That is great. We also want to go ahead and make sure that all of our settings are correct in GDM's config file. So I'm going to do sudo vim etc gdm3 custom.conf. For those who don't know, this is a text editor that you can use in the terminal. So I'll open that up. This line here that says Wayland enable false, we actually need to comment that back in so that it takes effect. I can, in Vim's kind of a complicated text editor to use if you haven't used it before. It has different modes. Right now I'm in what's called command mode, where I can sort of walk through the file, but I can't actually edit the file. Like if I hit a key, which I'm doing now, nothing happens. It just sort of moves me around in the file. If I wanted to edit, I can do I. So now I'm in insert mode. See, there's the word insert down here. And now I could, do stuff like navigate to this Wayland enable line and hit backspace. And you'll see it's now helmeted back in. We're going to be using some tools to connect to this instance because we're going to be doing it remotely over the internet. We'll use a remote desktop tool called Nice DCV. That tool doesn't like Wayland, which is sort of the new alternative to Xorg that Ubuntu is using. So we need to make sure that's turned off. All right, so I'm still in insert mode. To get out of insert mode, I need to hit the escape key. So I'm going to hit ESC on my keyboard. You'll see the word insert has now disappeared from the corner here. Great, that's good. And to leave, of course, again, it's super complicated. I hit the colon key to let Vim know that I'm entering a command, and then I hit WQ for write and quit. So we're going to do that, WQ. Sorry, I didn't really mean to make this a Vim tutorial. I just don't want anybody to get stuck here if you've never used Vim before. So colon, WQ. You'll see the commands I'm typing in, they'll show up in the lower left. And I hit enter, and boom, we're back in the terminal. All right, great. So that is done, and of course we need to restart the GNOME Display Manager for that to take effect. So we'll do sudo systemctl restart gdm3. All right, fantastic. Okay, that is going to take just a second. The next thing we need to do is make sure that the system is actually going to boot up to the login screen, to the desktop environment, right? Obviously, we're in a terminal window here, so there's no way for me to visually confirm that. But what I can do is I can do sudo systemctl get default. And it'll tell me what the boot target is for the machine, effectively, right? And it's graphical.target, which is correct. That's the one that we want. So now, if for whatever reason this wasn't the default target, then what I would do is I'd just do sudo systemctl and we do set default, right? Set default helps if you spell things correctly. Graphical.target, that would force it to be the target, right? And then what you do afterwards is sudo systemctl isolate graphical.target. Now that should be what we get every time we boot up. And we should also make sure that Xorg is actually running, right? That's going to be our X window manager there. So let's make sure Xorg is running. grep-v grep. Okay, so you can see userlib Xorg looks like it's running. In this path here, you can see GDM, so we know that we're using the GNOME Display Manager. So everything looks good. It's working the way it's supposed to work. So everything's good. What we don't have yet, though, is any ability to use OpenGL or do 3D stuff, which we're going to want once we switch to the NVIDIA drivers. So we need to install some extra OpenGL packages. So we'll do that with sudo apt-get-y install Mesa utils. All right, great. That is now done. All right, great. Cool. And of course, now I need to run a really complicated and long command. The link for this command is actually, there's a blog post where I wrote all this up. The link for that is in the description. I'm just going to paste it in. It's this super long command here. It's going to run glx info and tell me whether or not all the OpenGL stuff is installed. And you can see that it is. So it's working. And now we're actually getting up to the point where we can begin to install the NVIDIA drivers, which is where we want to be. So yeah, you can see this is a lot of work. So if you're doing something where you just need to run a GPU-enabled Docker container or something, you really want to be using the one of those NVIDIA AMIs that has the driver built in. Doing all this by hand can be a real pain. I just think it's nice for people to know how, which is why I'm doing all this. All right, so sudo apt-get upgrade -y linux -aws, right? We need to make sure this Linux AWS package is installed because some of the stuff we're going to need to build a kernel module is in here. This can, by the way, cause a new kernel to get built. You can actually see that has happened here, right? It says newer kernel available. All right, so you should consider rebooting. So we are indeed going to have to reboot. So again, we'll take a break to do a reboot to make sure we're running the latest and greatest console. Then we'll rerun this install command just to make sure that we're really on the latest kernel. Then we can move on to actually installing the drivers. So again, that'll terminate our screen session. It'll kick us out of our systems manager session as well. We'll just wait for that to reboot and then we will continue on. Okay, so we've reconnected. Let's get back into our Ubuntu user here. No screen sessions because we rebooted. Make a new one. And once again, we'll do sudo apt-get upgrade, and we will just make sure this Linux AWS package is fully up to date, which it is. Great. You can see this is 6.8.0. Wow. I can still remember kernel versions way earlier than this. I guess I'm old now. All right, so sudo apt-get install gcc make, and of course the Linux headers for whatever version of the kernel we have. A little hack for that is to enclose the uname-r command in parentheses and put a $sign in front, and then the shell will expand that out to the actual version, and then we'll fetch the correct package. I should say, though, that we are going to have to do an extra step because Ubuntu has made a very interesting choice, and I'm not going to go into the details because I'm not really a kernel or a compiler expert, but this latest version of the Ubuntu kernel that we're running here, let me show you again. This one, 6.8.0, this is actually built with a different version of GCC than what's installed by default in Ubuntu 22. So by default, Ubuntu 22 uses GCC 11.4, it looks like, right? So you can see that. Problem is, this kernel was built with GCC 12, and if we go and try and build NVIDIA drivers for a kernel that was built with GCC 12, but we're using 11, bad things will happen, right? It's not going to like it, so sad face. Bad things will happen. So we actually need to install GCC 12 and actually make that our default compiler, which is not super hard to do. It's actually a pretty straightforward process, but I just want to put that out there that that's something that we are going to have to do that we wouldn't have had to do before. So the steps, and just at the time I'm recording this, I haven't updated the blog post that's linked to in the description. Hopefully by the time I post this, I will have done that. But anyway, the steps are sudo apt-get install, and then we're going to do reinstall GCC 12. Just really make sure it's there. And you can see actually it is not. So yes, go ahead and install GCC 12. And then we actually want to make this the default GCC. I don't think this will mess anything up. Hopefully there aren't any, I mean, if you're building software against GCC 11 and you need to keep doing that, then you might have to switch back later. But for now, we're going to link user bin GCC to GCC 12 directly like this. So we're going to create a symlink from user bin GCC 12, over to user bin GCC. And you could set this back later. You could run this command again to change the 12 to an 11 if you need to do that for any reason. But now when I run GCC version, you can see that it's 12.3. So that's just an extra step that we have to do. So I wanted to make you aware of that. We also need to make sure, and again, this is something that's already in the blog post, so I'm just going to paste it in because it's too long to type. We need to make sure the mod probe blacklist contains other graphics drivers that could interfere with the NVIDIA drivers. So you'll see I have a whole list of them here, like VGA 16FB, Nouveau, I think they are, Riva FB. These are like other graphics drivers that could maybe interfere with the NVIDIA ones. So we just add them to the blacklist, and let's just make sure that worked. So we're going to go to modprobe.d, blacklist.conf. Just make sure they're in there, and they are. It looks like they're in there. So all good. That worked. Next thing to do, we actually need to be super aggressive about making sure that that Nouveau driver doesn't load up. So I also need to use Vim again, and I need to go to etc default grub and actually change the bootloader settings. So I'm going to go all the way to the bottom. If you're wondering how I got to the bottom so fast just now, it looked like my cursor just kind of went down there on its own. The command for that was Shift plus G. That'll take you to the bottom of the file in Vim. And then if you want to go to the end of the line, if you're too lazy to go down to the end of the line like me, the trick for that, I believe, is $sign. That should take you to the end of the line. Let's try that. Yeah, so I'd hold down, oops, sorry. I have to hold down Shift, and then I'd hit $sign, and yep, takes me to the end of the line. I can then hit I for insert. You can see I'm now in insert mode because I hit the I key, I for insert. And I'm now ready to paste in yet another line to explicitly blacklist this Nouveau driver. So we've now done that. I hit escape, WQ, that's write and quit, hit enter, and we are done with that. So if I were to then do cat etc default grub, I think I can read it without sudo, so let's try that. Yeah, you can see down at the bottom, there's the line I added. It's there, it's doing what it's supposed to do. And we're now at the point where we can fetch the drivers. And the drivers, the NVIDIA drivers for the Tesla T4, there's a bunch of different types of drivers. The NVIDIA documentation has a whole rundown on which ones to use. I'm going to save you some time. We're just going to download these drivers. Again, I'm pasting this in from my blog post. These will work fine for setting up a graphical desktop and doing stuff with CUDA, which is mostly what I want to do. So, sorry, we're actually not at that step. I spoke too soon. So what I'm doing first is I'm actually installing the AWS CLI. We will also fetch the NVIDIA drivers from an AWS location, but it's going to be not here. It's going to be an S3 bucket, which is why we need to install the AWS CLI first, because we need that in order to get stuff from buckets. All right, so I then do AWS install, sudo AWS install. That should install it. Great. You'll see I've got a bunch of junk in my home folder now. I can get rid of this AWS folder if I want. I don't need it anymore. I can get rid of the AWS CLI zip folder as well, zip file, excuse me. If I run AWS version, should work. If I run ls, you'll see a list of all my super secret buckets that I have. You can see I've got some buckets set up for static websites that I run. Maybe I'll talk about how to set up a static site in a future post, future video. All right, so that's all working. Now we can go to S3 and get those NVIDIA drivers I was talking about. So it's this command. Again, I'll just paste it in. And you'll see latest, we're going to go to EC2 Linux NVIDIA drivers, which is actually an S3 bucket name, belongs to Amazon. And we fetched those, and sure enough, here's a package. It's a package file, and of course I need to make it executable with chmod plus x, right? So we'll do that, and then I need to run it. So we actually want to run this in its own separate sh shell environment. So the command is going to be this, sudo /bin/sh, and then a dot to say I'm running an executable that's in the current folder, and then the name of the executable. There's usually like a version tag here that changes all the time, so I've just replaced that with a star, and the shell will automatically expand that out to be all this text here. So we just do that, and then we hit run. And actually, I've forgotten if I'm in a screen session or not. I really should be. I hope I remembered to start screen. If not, I'll just try not to navigate away from this page and hope everything goes okay. So you can see we now have to build the kernel modules, which takes a minute. So, probably about 5 minutes to finish this process. So we'll just sort of fast forward through this. All right, you might get some messages about do you want to install the 32-bit compatibility libraries or not. To be totally honest, I've never figured out what exactly I would need these for, but I usually just pick yes. So I just hit enter. It might complain a little bit, make sure you've got package config installed. This is not a serious warning. We can safely ignore this, so I'll just say okay. And then it will run a couple more install steps for us here. Once this is all done, then next time we reboot, this kernel module is going to load up. So it says, yeah, you have now installed the latest drivers. I say, okay, great. And now before we're able to actually see those working, we're going to have to reboot, right? So I'm pretty sure if I ran NVIDIA SMI right now, No, actually, look at that. You can see them right away. So I guess we don't have to reboot, but it's probably a good idea. So I'm gonna do that. But you know what? Before I reboot, there's one thing I need to do. I need to set up an NVIDIA.conf file here in etcmodprobe.d. And I'm gonna echo, rather than using vim, I'll just use the echo command to force some text into there using T. This is T, by the way. It's a handy way to append text to the end of a file from standard input, which is where stuff goes when you use echo and a pipe. Again, probably a topic for another day, but this is going to have the effect of writing this in to this file. I want that to be in there to disable GSP. I've been told that this needs to happen in blog posts that I've read and other places I've looked. I'm not honestly sure exactly why, but we're turning off GSP because people told us to. And now, before we proceed, we'll go ahead and reboot. Now would be a good time to reboot. Oops, oh, excuse me, should be sudo reboot, my bad. Oh, screen is terminating, so that's good. We were in a screen session that whole time. So we'll come back in a minute once that reboot has finished. So obviously when you do manual setup like this with drivers and rebuilding kernels, there's a lot of rebooting. Okay, so I skipped ahead a couple steps. I've already connected back up. We no longer need this driver installer, it's already there. If I run NVIDIA SMI, what is it, -Q, I think. You can see here's all the information. If I want just a summary, I can do NVIDIA SMI, right? And you'll see, sure enough, driver's running. I can see the properties of the card. I can see that it's a Tesla T4, and all that good stuff is showing up. To make sure that everything's going to work for us, I do need to make sure we don't have any legacy X11 configuration lying around. So looks like we don't. Because none of my tab completions are working here. But just in case, the full command to remove any old configs would be this. I don't think that's going to be an issue. Ubuntu 22 fresh install shouldn't have any. But we want to do that before we run this next command, this one here, and paste that in. Again, this is from the blog that's linked in the description. Before I run this, I want to make sure I remove any configs, which is the reason for that rm command we just ran. All right, so NVIDIA xconfig, preserve bus ID, enable all GPUs. Great. All right, it said it couldn't find a xconfig file and it couldn't find package config. None of that is a big deal, all just warnings. So we can ignore those. It looks like it did write a fresh xorg.conf file, which is fantastic. So it's working. You know, we can then go ahead and see, are we using the NVIDIA drivers? Again, we have this really hairy command here using glx info to pull a bunch of stuff about OpenGL out. If I rerun that, okay, not working, not using the NVIDIA drivers yet. We're not going to get output out of that command that's correct until we reboot. So to make this new xorg.conf take effect, once again, we reboot. So yeah, like I said, a lot of rebooting, very important, a lot of rebooting to do. So we'll do that, and we'll come back again in a minute when it's when we rebooted. Okay, so we're back in business, and I'm going to run that really long command again. This time it does work. You can see the OpenGL profile info is all reporting now that we're using NVIDIA drivers. So that's all working. Now we can do the last thing we need to do to really get to the point where we can actually log into this and have a remote desktop, which is install Nice DCV. And this is a really cool tool for managing a remote graphical session. And the really nice thing about Nice DCV is that it will work even if you're using an accelerated application. So if you're using something like, I don't know, AutoCAD or Blender, or you're doing some kind of thing where there's like 3D acceleration required, even running a video game, those things will work through a Nice DCV session. I wouldn't recommend trying to play a video game that way, but if you're doing something where you need 3D rendering, you can actually do your 3D rendering on a remote machine and access it over Nice DCV and use it just like it was, in front of you, just like it was a real GPU desktop on your desk, which is kind of cool. Okay, so let's go ahead and fetch the installer. That's the first thing we need to do actually, is get the GPG key and make sure we import the key so that the packages are signed and then we can install them, right? So we'll go ahead and do that. Once it's imported, you can actually delete it. So I'm going to get rid of the key. Now we pull down the nice DCV installer for 2204. This is the version of Ubuntu that we're running. We've done that. It's a TGZ file, a tar.gz. So we unpack that with, let's see, nice DCV. There it is. Okay, we've unpacked that with tar-xvzf. Whoops, sorry. I'm actually using a tool called Screen Brush to let me draw on the screen on my Mac here. And it just wanted some extra permissions. That's what that dialog was about. Nothing to do with our tutorial. Okay, so clear that. I'm going to do ls. You can see we've got a new folder now. And if I look inside that folder, excuse me, you can see there's a bunch of packages. We actually do not need to install all of those. I'm going to descend into that directory. So cd and then the directory name. ls again, you can see them all. We really only need 3 for the things we're going to be doing. There's a bunch of extra tools in here. I want the DCV server itself. I want XDCV, which is like for managing peripherals, because it will do like USB remotization and other cool stuff. And then I want the nice DCV web viewer, which will actually let me connect to my remote desktop through a web browser session, which is really cool and super helpful because that means I can get into this desktop from anywhere, anytime that I want. Okay, so that I need this one, this XDCV, right? I need the one above it, Web DCV Viewer, and I need DCV Server. Rather than typing in the full name of the deb package, I'm going to be lazy. Again, I'll copy paste these in from my blog post, and I've just replaced the version with a star so that the shell will expand it out for me. Because they're deb packages, I can just directly use apt install to install them. So we'll do that. So that was the server package. Then we fetch XDCV, and there will be some permission denied warnings and errors at the end. You can see, we've done this unsandboxed warning. That's dangerous. In our case, in this case, it's okay to do that, so we can ignore that warning. And then the last thing, so we've installed DCV, server, and XDCV. Last thing is to install this web viewer. And now we've done that. All right, fantastic. We also need to make sure that we create a couple new groups here, so all of our permissions are right. So we're going to user mod add to groups video and DCV. Then we're going to do sudo systemctl enable DCV server. Okay, we've done that, so it will start on boot. And then this is something important we need to do. We actually need to make sure the Ubuntu user has a password. Normally you wouldn't do this if you were, just using headless Ubuntu server. You do your login with an SSH key. But to get through the GNOME Desktop Manager login process, we're going to have to type in our username, Ubuntu, and then we're going to need to have a password, just like you would have if you had an Ubuntu desktop sitting on your desk. So I'm going to just pick a password I like. Okay, I've done that. And then the last and final thing we need to do is we actually need to make some updates to the DCV configuration file. This is actually super, super important. You probably want to go look at the blog post I linked to in the description to make sure you do this part correctly. I'm going to go sudo vim etc dcv dcv.conf, and there's a couple really important things we need to change. So under session management, you see there's this line that says create session true. I want to comment that back in. I want a DCV session to be running every time my machine boots up. Little hack here, you don't always have to go into insert mode in Vim in order to delete a character. You can just hit the X key. So if I hit the X key right now, that's going to get rid of that little hash and comment that in. So you can see there, that's commented in now. Great. I now want to go to session management. I think it's under automatic session. Let me see if I can find it. Here it is. Right, and there's an owner field here. This needs to be set to Ubuntu. The reason there's all this session management config is that NiceDCV supports multiple users, so I can have separate sessions and profiles for multiple different users. I just don't need that because I'm the only user of the machine. Again, I hit X to comment that back in. I need to put my username in the quotes, so I'll hit I for insert mode, type in Ubuntu, escape, :W, save the changes I've made so far. And then I need to find the connectivity section, excuse me. Here it is. And we need to add a couple of different things in there. I'm just going to paste them in because it'll be a little easier. So I'm going to find the bottom. You know what? I'll put them in the top. It'll be easier to see. I need to make sure certain ports are open so that I can connect. So let me add those. Let me add those bits. All right. So let me do that. Paste those in. And then one last thing, we need to enable quick front end. Quick is like a really high speed protocol. So it's great for doing desktop sessions. You'll have to open some security group ports to make sure that quick will actually work. I think it runs over UDP. I'd have to check. But anyway, I'm going to turn that on so that I have this ultra high performance quick protocol support so that my graphical sessions will run faster. The really important part though is, oops, you'll see I've accidentally reinserted connectivity there. We only need it once. Okay, the really important part is these two lines at the top here, these guys. You'll see that what I've done is I've started listening both IPv4 and IPv6. I'm listening on port 8443. That is just the port that I like to use for my sessions because it tends to be a port that's not blocked. So I can use it from pretty much anywhere, and it doesn't interfere with any stuff I might be running on regular port 443. Like maybe I'll have a web server running on my EC2 instance later. Don't want to interfere with that. Okay, so I've set my ports. I've turned on quick. I've set a create session to true. I've made the user Ubuntu. Those are really the only critical changes you need to make to this file. So I'll escape it, insert mode, WQ to write and quit. And of course, I think you can probably guess what's coming next. Well, first of all, I'll delete this stuff because I don't need it anymore. I like to keep my home directory clean. And of course, sudo reboot. And we'll come back once again and actually test things out in a browser once the machine boots back up. All right, so we're now at a really interesting step, a critical step. We are actually not going to go back here and connect through the session manager. We're going to try to connect through a web browser because remember, nice DCV should be running at this point. We should be able to get into the GUI. So I'm going to go ahead and click on that, which will copy the public IPv4 address to my clipboard. I'll open up a new incognito window here. Type HTTPS, we'll go ahead and do that. Put in the IP address, and remember, the browser is going to assume that HTTPS sessions go to port 443. That's not where DCV is running. We're running it on 8443. So I need to put in 8443 here, and you'll see, oh, we get a warning. That's okay. That's just because the certificate that's being used is a self-signed cert, right? So it says invalid authority. No big deal. We just hit advanced and proceed, and it says Amazon DCV. Actually, I should say Amazon now owns NICE, so I guess it's Amazon DCV, not NICE DCV. But anyway, I now type in my username and that password that I said earlier, and then I hit sign in. And what should happen is we should end up on the GDM, the GNOME Display Manager login screen, right? So now I can log in as any user. That first step was just to get me to the point where I can get to this login screen. Yes, I'll allow the clipboard to work, and you can do all kinds of stuff through DCV. It will let you do audio forwarding. It will forward your webcam. It's a really handy tool. Once again, I type my Ubuntu password back in here, and we should wind up getting the Ubuntu desktop welcome prompt. We should actually just be in here. And you'll see there's printer forwarding too, that little message that popped up about a printer being added. That's the DCV virtual printer, so if I want to print something from here, I can forward that back to my local machine. And of course, there's all this Ubuntu Pro sign up stuff. No, don't send system info, thank you. No, I don't want location services. Done. All right, great. So now here I am, regular old Ubuntu desktop. I can reboot, I can shut down, I can forward my microphone, speakers, camera, install packages, anything I want. And of course, again, remember, this is all 3D enabled, right? So all my 3D stuff should work. Might be a little slow. I'm doing everything through a VPN today, so not sure how fast it'll be, but you know, I can, if I run NVIDIA SMI, it's a little big, so it doesn't display nicely. There we go. I can see that my T4 is available to use. If I do something like GLX Gears, yeah, I know. So I'm going to say no to that. I don't want to upgrade to 2404. Yeah, I know, but please don't. So, all right, so great. GLX gears, and you'll see, look at that, 3D application pops up and starts running, and you'll see in a minute it'll start giving me approximate frame rates. It's like 9,000 FPS. I know that seems ridiculous, but it's pretty normal for GLX gears on a nice GPU. All right, so yeah, 3D applications work, everything works, and of course anything I do through the desktop, like reboot or shutdown, is going to go ahead and reboot or shut down the entire EC2 instance. So really, really cool stuff. Very handy. In fact, let's go ahead and do that. So I'm actually going to say, you know what, don't do any updates now. Power off, and we'll do power off. Yeah, shut down. And you'll see the session is closed because the EC2 instance has been terminated. And that's all there is to it. We now have a fresh working Ubuntu 22 graphical desktop. So hope that was useful, and I'll see you in the next one.